Hello, welcome everyone. Thanks for coming, especially right now that there's like 3 talks of the alternative realities and games happening at the same time. So thank you for being here. I'd like to know a bit how many of you here, because this is going to be a bit technical, but I'm not really showing a lot of code, but I would like to know how many of you are like front-end developers or like developers who work in JavaScript or similar. Okay. Oh. The similar did the trick. And how many of you do like real-time graphics and intentionally push information to a graphics card? Okay, good. Yeah, so thanks for knowing you. Who am I? I'm Ferran Bertomeu Castells. You can find me online at FontRBC. I grew up near Barcelona, but I'm now in Taiwan living. I've worked on companies like Go Technologies, an old company who did this JavaScript engine for the web, which is now dead because it was bought by Amazon and eventually just disappeared. But that's why today I'm talking about JavaScript-related stuff. But I do also do freelance game development work, especially in Unity. And for Apple Arcade, we've released this game recently, Disney Spell Track, for example. But I also do a lot of other smaller games, independent work, collaborations, yeah. And today I'm going to talk basically a table of contents about this project, the monkey catching game, about device fragmentation, three.js as a game engine, problems surfaced during testing, and what went well and what didn't. So yeah, let's talk about this project. Basically, the monkey catching game was a commissioned game by a Taiwanese indie band who contacted us that they wanted to promote one of their songs and they got some public funding for it. So yeah, why did they talk to me or to us in this case is because I've been working on games for music. This is 2 examples, which is like 2 interactive tracks that I invite you to try and play. So like we had some experience doing like games for the songs and for the stories of songs. So we got contacted by them, and the requirements basically were they just wanted like a retro style game. It needs to be a mobile, around 6 months delivery, but it was 6 months like half-time kind of for most of the team, even less, because they really had a limited budget, and nobody really understands maybe sometimes how expensive development time is. And this is like some images, which is a bit funny, but like there's an actual advertisement on a website about hiring a private investigator to find if your partner or special other is having an affair, because the game Catching the Monkey in Taiwanese means to catch somebody having an affair, and that was like the theme of the game. There's like a monkey theme also advertisement, which is the same thing. So anyway, like basically we were meant to make this game as a promotional game. So we wanted to support as many old devices because mainly this is going to be for teenagers, because the band, they speak in Taiwanese, they sing in Taiwanese, and recently it's like a very popular between teenagers. And in Taiwan, mainly it's like 50-50 iOS and Android, a bit more iOS and growing, but that's basically the audience basically again. Anyway, the team is very small. It was just Yenting Lo, who was doing production and sound effects, Nomi, who did the visuals, and me doing all the programming. So that's some work. We decided to go web over native. Native as in we didn't really make a Unity game or like try to release through the app stores because, well, it's just much cheaper and faster to update. Literally, our game is a static website. You just host it anywhere and send a link, and that's it. That's great. Again, this is great if you want to share. If you're on a concert or something for the van, they just want to put a QR code. You can just scan and then play this game. Yeah, and again, we're not looking for selling this game. This is just more like a promotional game. So we don't really want to sell it. So web makes sense in this case. We went JavaScript because I have worked in JavaScript, and yeah, I like to have the developer tools. I like to work on JavaScript. Coming from the Unity, I do a lot of work in Unity, especially. I like JavaScript on the website. It's very fast to iterate. I can just literally log my whole game, and I can see my whole game's memory, like state, basically, on the console. I like to do that. So yeah, we went with three.js for the 3D engine because I had tested before. I did some work, and it's in JavaScript. It's native, so yeah, it's nice. It's lightweight 3D engine. And for audio, we went with FMOD because we have previous experience on Unity, especially integrations with FMOD when we want to do adaptive music, or like we want to do some signals from the music to communicate to the game, and vice versa. Yeah, so this is the trailer. It's very short, so hopefully there's audio. That's it. It's very short. I'm going to just to show you, like, basically we have like this website we're hosting on itch.io, and then you can just literally just play the game, and which is this one, and then just to show you, to have an idea, it's like we have like some voice acting in Taiwanese, and then we support it with some text. I'm going to skip this, and basically on the game you have this character, and you move in the streets, and then you walk around. You sometimes fall, and yeah, you try to find where is the monkey. So going back to the presentation. Okay, so again, what does it feature? It features a WebGL render 3D world, which is a recreation of a street in Taipei, with a lot of moving elements like pedestrians. There's a traffic simulation going on too. And of course, like the world there's a lot of static elements. There's also some simple collision going on between the pedestrians and the elements in the world. And then we have this like virtual console around the canvas, like the WebGL canvas, which displays also some text that is contextual, because the game is kind of in Taiwanese, but we wanted to also like invite like everybody to play it who could speak English in this case. And it has some music related, adaptive music and time stuff. And you can take photos. A big thing about this game is you take pictures of the monkey. So let's talk about device fragmentation. Yeah, I guess many of you know that there's many mobile devices, of course, with a lot of screens, different sizes and whatnot. But then there's mobile browser fragmentation, which is its all other thing. Me coming from making games like for desktop, I was very scared. I expected like, oh, this is going to be, will have troubles like in the numbers of number of different devices times the number of different browsers, and this is going to be crazy. But actually, to be honest, after doing this, it's been more like the sum of both. It's been, yeah, there's some devices that have some specific problems, but once you fix that, mostly on the browsers, it works the same. Same with the browsers. If you find there's a browser that has an issue, usually it's on all devices. So yeah, for example, styling and positioning, many of you might be web related. I'm really not an expert on front end, let's say, but we early decided we want this console to look the same on all phones. We were trying to decide, can we do this like stretch and position things dynamically depending on the device? But in the end, it's like, there's too many. We don't have the time and the manpower to test if visually this is going to work everywhere. So we're going to with a fixed aspect ratio, but then there's things like, we want this border to always look the same, which is like a specific width of the console needs to be the border. And also we found out like, this aspect ratio in CSS, it doesn't really work everywhere on older phones, which is too bad because it's really useful, at least for us. So very early we decided, okay, let's just do it at runtime. We load JavaScript, we do the calculations, okay, how big is this window, how much we have to play with, and then we just set it on CSS variables, and then that changes the look. Like it takes a bit, it takes like a couple of frames or whatever, but it's worth it. We wanted to also, fight with the aliasing, which I don't know if you can tell. You see these red-brown pixels? They're supposed to be the same size, but how many sizes and shapes do you see, right? It's like, there's a lot, because we are rendering basically this game on a 96 times 96 frame, let's say, and we cannot really just work in multiples of 96 for it to look exactly perfect, because that would mean like scaling sometimes down a lot the screen. So in the end, we're just like, well, we're just going to embrace that this looks kind of junky, but it's like kind of arcadey game, so it doesn't look too bad. Yeah, as I said, there's another issue about displays, which is we really wanted to take the most of the display, but this thing in JavaScript, basically, you cannot really request full screen on iOS, which is too bad again. Yes, if you do like a progressive web app, you can get around it, but then you have to do a progressive web app, and we're hosting on a game site, which is itch.io, because we wanted to also get some people who played games to find this game out, like naturally. So we didn't want to just host on our website. So we decided like, no, it's okay. We have to work with what we have. Also, this thing about the window size, especially the height, nowadays how dynamic, like browsers just dynamically hide and extend the view of the window size, right? Like the URL will disappear sometimes, or it will change size. Shit. That's basically that's how I would express my frustration in a way. And then if any of you have animated on JavaScript for the web, basically we're depending on the request animation frame callback, right? And the thing is, the frame rate of this really depends on the device, the device screen, the refresh rate of the device, also energy settings sometimes. So yeah, this is not something we can choose or can be requested. That coming from games, it's not how we would do it. And then audio, yeah, this is supposed to be a music game, but we're making a game for mobile. But people on mobile are not necessarily listening to your game. Maybe they don't have headphones on. Maybe they are listening to their music. And also from a browser, you need to, this whole thing about like you need to interact to play a music. The music will by default play over whatever is playing on the device. So I still haven't found a way, like please let me know later. But basically because we're not really streaming a source, so like our audio really is going to play at the same time of whatever is playing on the device. And things like, is the phone's audio muted? We don't know. By privacy reasons, I suppose, we cannot know. From the browser, you just have to hope that you inform the player enough for them to turn on the audio. Yeah, so let's talk about three.js. Three.js, how many of you know actually three.js? Okay. Yeah, so it's an open source JavaScript native graphics library. It's nice. Like the minified version, uncompressed, it's like less than it's like 600 kilobytes. And it really includes everything, like from maths to communication with the graphics card, the GL calls, with the shaders that mostly you are going to use, like materials. I did some custom ones, but you really don't need to. It's very, very useful. And documentation, community is really, if you have any problem, you just share something on their Discord, and you will have like feedback and solutions. It's definitely very nice. What is not so nice, I have found? Well, we're working in JavaScript. Everything is on the heap. Everything is pointers to places in memory that you don't really know. For example, I don't know, like this is the matrix 4x4, which is one of the most used classes, let's say, on the three.js. Like the elements themselves is just an array. It's just JavaScript array. How is this implemented, like on the physical memory? It depends on the browser. It depends on the browser implementation. It depends on the JavaScript runtime. It really depends on what things you do with this array. Are you nulling or undefining some things? Then it might change from like an actual floating point numbers array to something else, which is just like a hash map. Yeah, it's really, you just can hope that the browser does the best work. And to be honest, it is very performant, especially on modern browsers. Like there's like the whole discussion in Well, let me talk about this first. Basically, there's a lot of multiplications that need to be done between vectors and matrices on three.js when we're computing the different matrices that need to be pushed to the graphics card. And specifically in WebGL 2.0, which is what three.js is using if you choose, you should. They're expecting this float32 arrays, which is like this native arrays in JavaScript. But things are going to be anyway casted every time you need to send information to a graphics card from the JavaScript array, which whatever it is, maybe it's like a 64-bit because the device is 64-bit, and it's like 64-bit floats, then it's going to be converted to float32 arrays, and it's going to be sent into the graphics card. So this has an overhead, but it's an overhead that you kind of have to live with. In JavaScript, this is more or less the architecture. This is from the three.js website, right? You have the scene, and then it's like a hierarchy. It's like a tree, a scene graph, no? And then this means like every time we want to render the scene, we have the renderer, and then we say, hey, renderer, take the camera, take the scene, and please render it, right? And then the renderer is going to take and go to the scene and update all transformation matrices, or like all model matrices for all the objects, and just go one object after object, updating all these matrices. It's actually a lot of calculations, taking all the position, rotation, and scaling that might have changed, and then building the matrix from that, and then taking that matrix into their children in the hierarchy, and then updating and multiplying that matrix times that matrix. Again, we're talking about the matrices are somewhere in memory, but not necessarily continuously, and also not necessarily, potentially they could be just all pointers. So this gets slow very fast. Like the moment this is like the most costly line in my game. And I have a lot of collisions detection. I have a lot of updates of objects. But like the most costly thing is updating the matrices for pushing the matrices into the graphics card. Yeah, it's there's an ongoing discussion about what I showed earlier about like the matrices living in like JavaScript arrays. There's people, there's being testing and people trying to, can we bring this into like a native array, which is consistent like in physical memory, like all the numbers are together. But actually, it doesn't really improve unless you have like a very big chunks, like very big float32 arrays in memory, and then you deal with this memory assignment yourself. Basically, what I'm meaning to say is like, it only makes sense if you're doing your own garbage collection and you're dealing with your own memory. But of course, we're working in JavaScript. We don't really want to do that. The whole thing about JavaScript is like, just create objects and then you release them, right? So there's an ongoing discussion. And also the web GPU is kind of changing everything, which, by the way, I think there's a talk on web GPU game making later. So I'm going to check it out. But web GPU might change a lot of things. So three.js basically has decided, like, no, we're staying with native arrays and with the consequences that that cost brings. You can do some interesting things. Like in three.js, you can do like the instance. You can basically, if you are rendering a mesh multiple times, you can, instead of sending it the information every time, you can just group all the matrices, all the position, rotation, scaling together of all these meshes and just push it once to the graphics card and then ask the graphics card every frame to please render all these meshes that I just asked before. Thing about this is like it really works for static elements, like in this case, like the trees, or there's like the parked motorbikes. This is extremely useful because really every time you put a new new motorbike park on the sidewalk, then you'd have to push this new information to the graphics card. Yes, you have to push all the information of all the parked motorbikes, but it's only once every 2 seconds. If in my case, where we're generating the world procedurally. But for moving objects, moving objects means objects that move every frame. No, for example, the pedestrians. In this case, I make them walk. No, I animate them on the CPU. In this case, I move their feet, or like, sure, I'm doing it by like some procedural animation, but you could also be reading animation that was authored by the animator itself, which we also are doing. But every frame it changes, and every frame you have to update all the matrices, and push it to the graphics card. So the moment that you try to instance, to make that all right feet of all pineapples are the same mesh, and you create like an instance mesh of all that, and you want to paint all the right legs or the left legs or all the bodies. Actually, these bodies are pretty complex too. There's several meshes here. But you can do that, and you're going to save draw calls, right? Like the graphics card is going to paint everything at the same time. And in this case, because they're opaque too, so it's really, you can save that. But what I found is like you still need to push all this positional information to the graphics card, and that's like the bottleneck. That the CPU cannot, the thing that's taking the CPU the most time is passing all the information to the graphics card every frame. Yeah, you can try to simplify, like there are ways, and I tried a lot of ways to not keep the whole object hierarchy and then keep things abstracted, but it is useful sometimes to know where the leg of this specific pineapple is. Yeah, so again, instancing on dynamic objects might save you draw calls, but not CPU time. And actually, mobile phones have nice GPUs. They have quite powerful GPUs that were not really running, like especially on web. So yeah, what did I find during testing? Yeah, we wanted to share these pictures that you take. You take a picture, and we want, maybe we can call this thing, which is the web share API, where you can just send like the file, which is this image, and then put a title and your URL. But since I tested this first before starting this project, which was more than a year ago, almost 2 years ago, that kind of worked mostly across devices. But then it actually has lost support since it launched. So it's like, I don't know where is this API going. But as you can see there, I don't know if you can see, it's like the web view on Android basically just doesn't allow you to download anything or share anything. So if I am seeing this link on an Instagram post and I click on it, or like an Instagram message, it's going to open the web view inside the app, and I'm going to play this game and have a lot of fun. This works just fine. But then the moment I want to share this picture, there's no way. Basically, it's going to just keep popping you errors. Right now, this is the case on Android, which is a shame. Yeah, it's a shame. And also, it's so inconsistent, the web share API between different browsers. Sometimes it will bring the URL that you just provided to it with this share information, but sometimes not, because you're also sharing an image. So then the image takes precedence. Is so complicated that, yeah, it's problematic. And then we have this problem that I encountered during testing, which is the audio cracking. I'm going to play a small video of basically the game running on a local server, an early version of the game. You can see the FPS is like around 50. And then I switch to something that I'm hosting on my server, and you hear the difference. Yeah, nice. You can see the frame rate is literally the same. Like it's not really that we're suddenly running much slower, but the audio really, it becomes shitty. And we found that even on desktop devices, depending on the browser, sometimes, and depending on the server, that would break. Yes, we figured out well, we're using this FMOD library, and basically FMOD is not managing to push all the audio information to the sound card of each device, right? Because the sound card needs to, it has a buffer, and we even tried increasing the audio size buffer to make sure that even if we didn't make it on this frame, because somebody is kicking out because we're spending too much time on the CPU, at least they have enough information. But actually, yeah, the whole thing is about, yeah, JavaScript runtime is single-threaded. And in video games, one of the things that it's always on a separate thread is the audio. Because you want to make sure that while you're doing your whole physics simulation explosion, the audio doesn't do this, right? The audio needs to sound okay. And it's one of the only things that you really put on a separate thread. And in our case, we're using FMOD, which is proprietary code. So we are kind of limited, how is FMOD doing? Why is it not doing this? You can ask from FMOD, but it's not an easy task. And also the whole compression, are we compressing our audio? Are we decompressing on load or to occupy more memory, but then if it occupies more memory and you need to push it to the sound card, that's going to take more time for JavaScript because it's more audio, like more data to send and to process. So it's like you need to balance and try to figure out what is best for you. Yeah, so again, FMOD is in WASM. We don't really know. Unfortunately, FMOD is really not meant for HTML. And it does use web workers to do some of the work. What of the work, it doesn't say. It just says like, hi, if the cross-origin, basically if web workers are enabled, we're going to use it. And in this case, I'm pretty certain that that's our problem. The shared array buffers and the web workers are not available, and then FMOD is just not running as smooth as it could. Yeah, so that's a shame. And one of the things also you could see is like request animation frame in that device, for example, was supposed to be like 60 frames per second, but you can see that our game is taking its time. It's taking like 50 frames per second. We're not reaching 60 frames per second either. So we're like, okay, let's just maybe lower that. Like, let's take 60 is too much. So let's try to do 30. So basically that's what we did. Instead of, if we did detect that we're running at 60 frames per second, at least the graphic part and the update part of the game, we're just going to skip once every 2 frames. But then the audio, of course, we make sure that it pushes all the information it needs to the sound card. Otherwise we cry. So yeah, that kind of worked. So that's the solution on using the FMOD. Maybe run your game at lower FPSs in our case. Yeah, and that's the whole thing. That the beginning of this talk, the title was kind of related to this. It's like, I really don't know what's happening, and I really try to use different tools to figure out, okay, why is it, who is stopping me here, right? Like, is the browser or the CPU, the OS is deciding, hey, you are using too much CPU time, just wait for a bit, and then later it's going to put you back, so it's going to kick you. But then how much is too much also really depends on many things. Also detected that sometimes browser would change its behavior, like it would run smooth for a bit, but then run bad, and then run smooth again. And it's like, wait, are you changing some settings? Like, are you treating this JavaScript code like differently because you're thinking that maybe it's thermal throttling you or something? You know, like maybe the phone is getting hot for some reason. In our case, it's the graphics card is really not the biggest thing. It's the CPU, but still it could be, right? Yeah, and then again, the compression of the audio, you need to find what works. So anyway, that was the what went bad. What went well? Well, we tested on really old device. We took an iPhone, I think it was an iPhone 8, which was not fully updated, and we tried to make things work for it. Again, I really love coming from making games in Unity. I really love just updating the website and say, hey, can you go to the website and try see how it works? I really like three.js. It's very easy to iterate. It's so much content. Many times it's like, well, this class is doing something that is not exactly what I want, but you can just go copy it and then just edit and make it do. For example, in our case, the model importer, the FBX, we're working with FBX models, 3D models, but we wanted it to process it differently, so we just do our own FBX importer from the code that they have publicly available. So that's great. And again, in our case, since we're doing like this retro style, even though we're post-processing, we're doing like a post-processing pass, also we're taking pictures, and we sometimes have like several cameras, but like the GPU is not the one who cares much about it. Like mobile GPUs, even on older phones, they really can do a lot of computation. The CPU, in this case, running JavaScript threads, is what's the problem. Yeah, and draw calls and vertex count, unless you're really going crazy, if you're just trying to make a game, you cannot get away with it. I think that's what we learned. What would I do differently? I would not use FMOD. I would say if you're planning to do some kind of interactive experience, just use something that uses the web audio directly yourself, or just libraries like Howler.js. which is like a native JavaScript library that uses the Web Audio API. This web sharing API, it's just another thing right now. And then if you want to do complex graphics, you might need to not use the three.js paradigm of the scene hierarchy and such. You might need to do something custom yourself. You might need to, if you do custom particle effects, or like even for us, for the pedestrians, maybe if I had more time, just bring this whole memory management ourselves and make these updates of the matrices that we need to send to the GPU ourselves, and not rely basically on this scene graph from three.js, because really three.js is really not meant for a lot of moving parts, a lot of objects. Yeah, so you have to do this customly. Or also let the GPU animate for you. Really, mobile GPUs are very powerful, so we could have taken this pedestrian, this pineapple that we had, and then just put it on the graphics card, and then just make a shader that moves at the vertices how we want it, depending on some variable. So we just need to communicate to the GPU, hey, right now it's walking, and this is the time, so please move the vertices for us. So yeah, make use of the shaders if you can. And yeah, closing remarks. Thanks to Javier Genjo, Tamat, that helped me review a bit this. And you can play the game right now if you scan this code or you go to this URL. I highly invite you. It's a small, short game, 5 minutes. It's fun. Yeah, thanks for listening. Any questions?